Hello Legacy students, Marsh here. So today we're going to look at solving radical equations. Basically we're going to take our roots and exponents knowledge to basically solve equations that have square roots or cube roots or fourth roots or any kind of root in the equation. What you're going to want to have on you today, your notes, pen or pencil, and then you may want a calculator so you know where some of these numbers are coming from. So solving equations, what does this involve? Basically all you're doing is getting the x alone, just like we normally have. Using some inverse operations to do this. Some stuff that we haven't talked about a whole lot though is using a square root and squared opposites and using a cube and a cube root as opposites. So knowing how to go in and out of those two and using them to cancel out one another. And then also using some reciprocal fractions in that regard. Most like all the ones we've been solving recently, we also need to check our work at the end to make sure they actually do work and plug in correctly. So let's look at our first problem. I have the cube root of x minus 9 equals negative 1. So very first thing, I need to get this cube root of x alone. I need to get it alone so that I can basically cube it and undo that cube root. So what I'm going to do is add 9 to both sides. So I'm going to get cube root of x, this is going to cancel off, equals negative 1 plus 9, that is 8. Now what I need to do, guys, I have a cube root of x. I need to undo that cube root. So I'm going to cube it. But if I cube on this side, got a cube on this side. So that means cube and cube root are going to cancel off. So I will be left with x over here. And then I need to know what 8 to the third power is, which is 512. Now, before you're like, yes, we got it, Marsh, it worked. You do need to check. You need to make sure that the number you get works in the problem that you're working on. So, I need to do some checking over here. So I got the cube, whoops. I have the cube root of 512 minus 9 equals negative 1. So the cube root of 512 is 8. We can use our perfect roots chart for that. So I got 8 minus 9 equals negative 1. 8 minus 9 is negative 1, so thus it checks out. No issues. Trust me guys though, there will be some extraneous solutions that will come about in these problems. Let's try another one. Now you're probably looking at this problem going, oh holy, what is going on here? There is cube roots on both sides, that's gross. But you know what? This is actually the easiest problem. Because if to get rid of this cube root, I have to cube, right? Cube this entire side. Well, if I cube this side, I gotta cube that side. Notice, that's gonna cancel off, right? And be left with 2x plus 3. And then it's gonna cancel off over here too. Cube root of cubed. It's going to be gone. I'm going to be left with just underneath, x minus 1. This is the super easiest problem to solve. So let's get x alone. So I'm going to subtract x. I'm going to subtract 3. So that x is on one side and the numbers are on the other. That cancels, that cancels. I'm left with x, because 2x minus x is x, and negative 4. So I know that x is equal to negative 4. Now, before you go any farther, please guys, check work. So cube root of 2x plus 3. So cube root of 2 times a negative 4 plus 3. Well, that's cube root of negative 8 plus 3. That's negative 5, right? Which this is some number, cube root of negative 5. That is fine. You can cube root or fifth root a negative number. Now, let's plug it into the other side. So I have the cube root of x, which is negative 4, minus 1. So that would be a cube root of negative 5. Well, these are equal to one another. So it does work. Negative 4 is, in fact, my answer. Let's take a look at this one now. So it looks like, guys, I have to square this side, right, to get rid of that square root, because there's technically a little 2 there if there's not a number there. Here's where this caution is coming into play, guys, because I'm squaring this entire side, not just the 1 or not just the x. I'm squaring that entire side. Well, x plus 1 squared means x plus 1 times x plus 1. Gotta write it twice. So nice, gotta write it twice. And this would be equal to 7x plus 15. Let's FOIL out this side. So I got x squared plus 2x plus 1, right? X times 1, 1 times x. Yep. Equals 7x plus 15. Let's get everybody to the same side, shall we? There we go. That's canceled off. Equal to 0. So I got x squared, negative 5x, negative 14. So, you know what? I bet our factoring knowledge is going to be useful right now. Factoring, because I got an x squared and I'm set equal to 0, so we need to solve using factoring. So we're going to use our AC method, so 1 times negative 14, that is negative 14. So numbers that multiply to give me negative 14, but add together to give me negative 5. That would be negative 7 and 2, I think. Right? Yeah, that's negative 5. So I would expand my middle term, I would do some grouping, and ultimately I would get an answer of x minus 7, x plus 2, right? And since my a is 1, I can just go right to that. So I know either x can equal 7, because x minus 7 equals 0, or x can equal negative 2. Now, before you jump on and go, yay, I got the answer, check your work. So we're going to check over here. So I got 7 plus 1, that is 8. Let's check the other side. So I got the square root of 7 times 7 plus 15. Well, that would be 49 plus 15, which is 64. So this is technically the square root of 64, which is 8. So 7 does in fact work. No problems with the 7. Let's try this negative 2. So I get negative 2 plus 1, that is negative 1. Let's plug in the other side. So I'll get 7 times negative 2 plus 15. So this would be, well, that's negative 14 plus 15, that's 1. So I got the square root of 1, which is just 1. So I got negative 1 equals 1. Well, that's not right. Negative 1 can't be 1. Dang nabbit, I have an extraneous solution at x equals negative 2. So my only answer that works in this problem would be 7. Keep that in mind, guys. Sometimes extraneous solutions will happen. That's why you need to check. Especially the ones you need to check are the ones that have a squared and you have to factor at the end. Those are the ones that most likely you'll find yourself encountering an extraneous solution. But that's the end of this video. See you later, Sabers.